Hello. Hello. Testing. Is this thing on? I think it's on. I think you can hear me now in your headphones. Hi. Today we're talking about products of decimals. We're actually gonna just get into it. We're actually gonna get into multiplying decimals. So we spent the last couple of days using some estimation strategies, think about number sense, even doing some base 10. But today we are literally going to dive into something like what happens when we have to multiply something like 1800s times 4. And that's what today's all about. We are going to be looking at the fact that we are going to just only be multiplying decimals and whole numbers. Okay, so we're not multiplying decimals times decimals yet, but today we're just going to focus on this concept of whole numbers. I love steps, so we're going to do that today we're going to first start, we're going to estimate. We are then going to stack and add, and then we're going to compare for reasonability. So that will make more sense as we go, but that is the concept of our lesson today. Some sort of today's math is happening. So let's dive in. Let's just kind of do that. So step one, estimation. Now, this was that tricky part that we've talked about, right? Because there is always like the simple right away. Oh, front end estimation. Well, there's no holes here. This is pretty close to 0. So that's going to get me 0. Yeah, that's one way of looking at it, but we are trying to be a little more accurate. You could also say, oh, I'm around this all the way up to 1, and that's going to get me 4. But we also know that it's actually less than that. So it's somewhere that lives in between these two numbers. So being a little more in depth about our estimation on like what exactly would this be. And so we can unpack that a little bit, right? Oh, there it is. It did that weird thing where everything disappears. Hold on. Oh boy. Okay, cool. So we can unpack this a little bit. There we go. Much better. And thinking about like, well, what is 1800s, right? And I actually might say, oh, well, actually 1800s is trying to like get this back up. Actually, that's kind of close to 2/10 or 2000s, right? And again, this kind of gets me in that base 10 world. I mean, it does, but it's not really in one that really helps me think about the way we do base 10, but it does make things a little bit easier to work with because there's that 0. It's always good to kind of have a 0 in there because things can work a little bit better. And then I actually probably don't even need to do anything with the 4, so I'll keep the 4. So I'm kind of estimating here. Now, again, I know this isn't full estimation when you have to do this much work, but let's break that apart then. If you think like 2/10, well, if I don't know, let's just even go with the number 1. And this is gonna be cool because this will actually come into like handy of like the skill we're doing today. I don't know, I break it into 10. So let's see, there's 5/10, 6/10, 7/10, 8/10, 9/10, 10/10, 1, 2, 3, 4/10. So that's 1/10, 2/10, 3/10. Oh, that's why I like going every other. It's hard to squeeze them all in there. 6/10. I'm gonna come back up here. 7/10, 8/10, 9/10. Okay. Okay. So I guess what my point is we're actually working with 2/10 or 2000s, right? Those are the same thing. So this is kind of like where I'm at right here, like 2/10. And actually, I have 4 groups of it, right? So I could think about this as like as doing that, like those jumps. Like here's 4/10 or 2/10, and then if I did one more jump counting by 2/10, I'd be at 4/10, and then 6/10, right? So one jump. Oh, I should have done a different color. This is a disaster. Hold on, I gotta go to the other page. I don't like this. I gotta make this clear. All right, so where I had rounded to 2/10 times 4, and this was my point. So this is a little bit bigger. I like this. Okay, cool. Let's go back. Put in these tenths. Right? That was a disaster. You're probably like, I can't even read that. That doesn't even make any sense. And I'm like, yeah, you're right. It does make sense. And then I was like, but watch this. I'm gonna do it all over again. You're like, I don't have time for you to do it all over again. And I was like, yeah, but you want to learn anyway. Okay. So where was I? Okay. So we were talking about this concept of we're working in groups of 2/10, right? And there's actually 4 of them. So if we look at it in a number line, I'm actually taking that leap in a sense. Like if I did I'm gonna go down here. If I did one jump, that'd get me to 2/10, right? That'd be one jump. And then I'm going to do a second jump of 2/10. I'm counting by 2/10, which is the same thing as counting by 2. So I just end up at 4/10, and that would be 2 jumps. And then my third jump, right, would get me here. So that would get me at 6/10. Oh, I don't have to write that down here. That's right here. And then my last jump, counting by 2s again, would get me to 8/10. So actually 4 groups of 2/10 each. Roughly, my answer would be about 8/10. And this is all for that estimation. So if we go back to this, that kind of makes sense, right? I know that roughly my answer will be around 8/10. Whew, that was rough. Okay, so now let's go into this next step. And this is actually where I really want to unpack this. So this is 1800ths times 4. So I'm going to skip all this craziness. We're going to come back here. And here's the real problem I'm solving, 1800ths times 4. So this is kind of what I was getting at with that number line is if we remember what multiplication is, remember multiplication is just groups of things. Multiplication is also skip counting. That's one thing we tend to always forget is that multiplication is literally skip counting. So when I say something like, what's 5 times 3? That's me counting by 5s 3 times, right? 5, 10, 15. There's my answer. Or if we say something like, oh, well, what is 6 times 3? Well, that's me counting by 6s 3 times. So 6, 12, 18. Gosh, I used 3 both times. So let's use another example. Well, maybe it's 6 times 8. And I'm like, oh, okay. Well, that's me counting by 6s 8 times, which I actually don't know how to do that. So I could go back to this other, now I got to create space. Sorry, hold on. I can go back to this other realm then of saying, oh, well, I don't know. I counting by 6s isn't my thing. I'm not going to do it 8 times, but I do know that this literally is the same thing as 6, 8 times, right? 1, 2, 3, 4, 5, 6, 7, 8. And so I could look at it this way through repeated addition. I could say, oh, okay, well, that's 12, 18, 24. This is also, so 48. So 6 times 8 is 48. And again, I could achieve that through skip counting or that concept of repeated addition. That's multiplication. And the cool thing about multiplying decimals then is that is exactly what I can do. That same concept is going to help me be successful in a problem like this. So if we look at 1800ths times 4, well, guess what I'm going to do? I'm going to treat 1800ths times 4 as 4 groups of 1800ths, meaning I could look at it as 1800ths plus 1800ths plus 1800ths plus 1800ths. If you need the zeros there, I'll put them in there. And I can just use repeated addition because actually we do know how to add decimals. So let's do that. I am literally going to just take and stack, my 1800ths. I'm going to do 2 of them right now. Remember, I have to do 4, but I'm going to do these 2 first. Let's see, 8 and 8 gets me 16. 1, 2, 3. Decimal drops. That still stays there, which means then this 1800ths and this 1800ths is also 3600ths. So I'm going to have 3600ths plus 3600ths, which gets me 7200ths. So actually 18 times 4, the real answer is 7200ths. And if we go back to our estimation that was somewhere in all this craziness, I think we estimated 8/10 or 80/100ths. So that looks about right. Okay, so that was 8 minutes of confusion and 14 different screens and all these different colors and wildness. So let's just draw it back and go back to step 1 and try another one of these problems. Let's say we had something like 7/10 times 3. Okay, so first estimation, I think I could estimate. I like this one. This rounds to 1 pretty quick. So I will estimate about 3. And then now let's do that repeated addition. Remember that 7/10 times 3 just means I have 3 groups of 7/10. And if I have 3 groups of 7/10, well, I can just add those up, right? 7 plus 7 is 14, plus 7 more is 21. So my 1 goes here, my 2 carries here. Decimal is so heavy, goes thump. And there's my real answer. 7/10 times 3 is 2 1/10. And if we go back to our estimation of 3, I would say that feels pretty reasonable. Okay, all right, so let's try this on with some more. Let's do another problem, because other problems are good now that you're kind of hopefully seeing what we're doing. What if we had 1200s? Oh no, let's do this. Actually, I lied. Let's go with I think what we haven't done is maybe like a whole number. Let's do something like 1 4/10 times 5. Okay, so again, same idea, right? Because I have a decimal and because I have a whole number, and this works with the whole numbers. Like I said, it's the only thing we're going to focus on today is our first step into multiplying decimals. So all I'm saying is I actually have 5 groups of 1 4/10. So that's 1 4/10 plus 1 4/10 plus 1 4/10 plus 1 4/10. 1, 2, 3, 4 plus 1 4/10. That's 5. And so now let's just add those together. I like to do it in groups. So I'm just going to start with 1 4/10 plus 1 4/10. So that gets me 8. Decimal drops 2. So 2 8/10. So that means this also is 2 8/10. So I'm going to add those together. So that's a 6. So that's 5 6/10. What was our estimation? Oh, I didn't do an estimation. Oh my gosh, I got right into it. Sorry, I forgot to estimate. Anyway, and then 1 4/10. So let's see here. That's 6, 7, 8, 9, 10, 5, 6. Oh, that actually gets me 7. So the reality is that answer is 7. I guess had we estimated, I can't believe I forgot to estimate. Shame on me, bad teacher. Let's do that real quick though, even though remember always estimate first, but I guess you're right. We could call this 1 times 5, and that would get me about 5. So that looks good. We also maybe round it to 2, and that would get me 10. That also looks good. So 1 4/10 times 5, the real answer is 7. And that can happen. You can actually multiply a whole number and a decimal and get a whole number as an answer. So that's pretty interesting. That might happen. So repeated addition, it's actually a really good way to approach this. So let's just do 2 more problems because I feel like this is pretty straightforward. And then again, don't hesitate to ask questions. All right, next, let's say we have 1200s times 100. Whoa, wait. Whoa, wait. I'm not going to write this down 100 times. I'm not going to sit here and go 1200s plus 1200s plus 1200s plus 12. 100 times? What are you, crazy? That's crazy talk. That's wild. I wouldn't want to do that, which actually I'm being dramatic for no reason, because hopefully you're screaming at the screen. Well, actually not, because we're working, but in your head, you're screaming at your screen and you're like, dude, this is base 10. We already know how to do this. And I'm glad a problem like this just popped up on us, because it's one way to make sure we don't forget the things we already know. Something like 1200s times 100. I don't have to write it down 100 times and add it together. I actually know that this is that work with base 10, where again, 1 times 12 is still 12, but it's not 12, it's 100 times greater. So that means if we think about that number line, or that place value chart, sorry, I don't like this base 10 I wrote here. I got to get it out of the way. That things are shifting and moving. That's all that means, right? We have it in the hundredths place, and then we have it in the tenths place, and then there's the ones and the tens and the hundreds. Well, and this is the decimal right here. So if I had this, well, I'm getting 100 times bigger, which is 1, 2 place values. So everything's going to move 2 place values. So this 1, maybe draw a grid like this. This is a grid we're familiar with. This 1 moves there, and then it moves here, and the 2 moves here, and the 2 moves here. So actually we end up with just 12, right? That base 10, how many times does it move? Because I'm multiplying by ones, tens, hundreds. Okay, great. So that came up. We don't have to do repeated addition with a problem like this because we know how to do that. So pay attention if you see a 1, a 10, 100, 1,000, 10,000, 100,000, whatever. Remember base 10 multiplication. But let us remember that sometimes it will not be as friendly, and we might have something like 2 3/10, and we have to multiply it by 6. Now this is where I can use repeated addition, because again, what it's asking me to do is I'm taking 2 3/10 and I'm adding it. I have 6 groups of it. So I'm doing repeated addition 6 times. 1, 2, 3, 4, 5, 6. And again, I don't like doing them all at once, but in this case, I stacked it that way, so I'm gonna have to. So let's see, 3, 6, 9, 12, 15, 18. And then 2, 4, 6, 8, 10, 12, and 13. And then there's a decimal, and there we have it. And again, I forgot to estimate. Oh my gosh. Horrible, horrible teacher. Fire me. I need to be fired. 2 times 6, so 12 about. So yeah, that checks out. But again, I shouldn't be estimating after. Well, I guess I could, but I like estimating first. Anyway, there you have it. That's it. That's it. That's multiplication of decimals and whole numbers. Treat it like repeated addition and your life will feel good. And don't worry, as of today, this is the only strategy you can think about using because the problems will be very friendly for this. Yes, in the future, we're going to have something like 3 8200ths times 4 9/10. Repeated addition is not going to work for a problem like that. And we'll talk later when we get there what kind of strategies. But as of now, when multiplying a decimal and a whole number, think about using that repeated addition. Okay, that's it. I'm signing off. I feel like this video was very scatterbrained, so hopefully it made sense to you. If not, you can ask questions because it's not your fault it doesn't make sense. It's this video's fault. So check in with me, ask for assistance, and let's make sure we get the job done. And as always, I appreciate you. We'll see you later.